Alright, so today we're doing Unit 6, Day 7, Intro to Trigonometry. And so we're going to just review some things we know about right triangles. We know they have a hypotenuse. For example, the hypotenuse in this right triangle is the one across from the right angle, which is segment AB. The distance from A to B is that lowercase c. So remember, capitals and lowercases have important meanings in geometry, so make sure you're using the correct caps and lowercases. Okay? Then we have two legs. We talked about earlier with the 45, 45, 90 that both of those legs are equal. In the 30, 60, 90s, we know we have a long leg and a short leg. But today we don't care if they're long or if they're short or if they're equal. Okay? We just care that they are legs. Okay? One of them is this vertical one here, which is the segment AC. And the distance from A to C has a value of lowercase b. So notice when I'm talking about its distance, I'm not putting the segment bar over it. Just some notation that we should remember from way back in like September. Okay? And then my second leg is, you can either call it CB or you can put it alphabetical and put it BC. Either way, that's the same leg, BC or CB. And the distance from one end, oops, not A. The distance from one end of B to the other end, C, is that lowercase a. So when we did 45, 45, 90 triangles, we just referred to the legs as legs. When we did 30, 60, 90s, we referred to one as short and one as long. Now we're going to have another way that we're going to refer to the legs, and it's going to be based on being at a specific acute angle. So it says, now let's look at this in a different way, and we're going to say from an acute angle. From an acute angle. When you have a right triangle, you have one angle that's right. The other two have to make the other 90 degrees out of the 180, so they're both going to be acute. Okay? So we're going to be having one that's from angle A. I put an apple for A for apple. And the other from angle B. I put a little b because B for B. Okay? Alright, so your hypotenuse is still where it always is. My hypotenuse is this side here, which we know has a length of c. That is my hypotenuse. I'm going to do it in pen so it fits better. Okay? Then, the way we're going to differentiate between the two legs based on being at this angle right here is one leg is right next to that angle, sharing the side of that angle. We call that leg the adjacent leg. So the side length of B is the adjacent leg. Okay? And then you have the one leg that's left, and it's all the way across on the opposite side of that triangle from this angle, if you go all the way to the opposite side of the triangle. So we call it the opposite leg. Okay? So that's if I'm standing at A for apple, if I'm standing at this angle up here. But, so we don't always stand at that angle. I might be standing at the B angle. So if I'm standing here at this angle, at angle B, my hypotenuse is not going to move. My hypotenuse is still that same side. It's always the same thing because it's always across from that right triangle. C, the side length C is still my hypotenuse. Okay? But now, if I'm at this angle, when I look at these two sides, now this is the one that is next to that angle. So now this one is the adjacent to angle B. So the side that has an A. Yes, Ileana?
Just one second. Thank you.
So now A is now going to be my adjacent leg. And then guess what B is going to become? This is now going to be my opposite leg. Okay? That is going to be, if you can learn to label these triangles, then you are like 90% on your way to being successful in this unit. Okay? So, it says you try first. You're going to label the sides as opposite, OPP for opposite, ADJ for adjacent, and HYP for hypotenuse. Those are the abbreviations we'll use for the whole unit. OPP, ADJ, and HYP. Label with respect to X. So with this first triangle here, we're going to be right here at angle B. A lot of times you'll see me put a little smiley face. With the second triangle here, we're going to be up here at angle A. So take about 30 seconds or so and label those triangles. And then we'll see if we get all the same answers. Alright, I know that wasn't very long, but hopefully it doesn't take too long. Does anybody need more time labeling their triangles? Alright, check your answer. If you got it correct, you can give yourself a round of applause. Yay, one golf clap. Yay. Alright, so really all that's changed is where your opposite and where your adjacent is, right? Your adjacent is always going to be closer to that smiley face, closer to that angle. Okay? So we're going to practice that a few more times just because that really is something that's super, super important in this unit. Okay? It really is something that's super, super important in this unit. If you struggled, if you got those in the wrong place, I'm going to give you some tools right now to really help you. Okay? The first thing you want to do every single time is identify the angle. What I'll usually do is I'll put a smiling face, and depending on how much time I have and how creative I'm feeling, sometimes I'll even add some hair and a body, all the things. Okay? So that's the angle I'm at. Then the next thing I do, because it never moves, is I identify the right angle and look at the side across from it and say that's my hypotenuse. So I always label the angle first and then the hypotenuse, because then I'll highlight that angle, because the side that's coming out of that angle that's not the hypotenuse, now I've highlighted it, and I know that is now the adjacent side. And also now it looks like there's like a little megaphone coming out of the person, so they're yelling into the megaphone because they have to reach the person who's on the opposite side of the room. Okay? So that's kind of how, if you struggled on those two try-it-yourself problems, if you just kind of take yourself through that little story every single time, then you should be okay, right? First, identify the angle. Put yourself there. Then, if you find your right angle and look across from it, the side that's not touching it is your hypotenuse. So then, the angle where the smiley face is, if you just highlight part of the sides that are coming out of it, the one that's not the hypotenuse is the adjacent. So now you can see the smiley face person has a megaphone and they're yelling to the person who's on the opposite side of the room. 2 more. Again, being able to label these triangles is the most important part of this unit, really. If you can label them correctly, that's like half the battle of the problem. Where's my hypotenuse on this one? The top, the left, or the right? The top. Where's the adjacent side? On the left. Which means across all the way is the opposite. Alright, and then this last one here. Here's my X. So here's my smiley face. Which one is my hypotenuse? The bottom. Which one's the adjacent? The left. So then we're yelling across to the opposite side of the triangle. Okay? The reason it's important to know where your opposite, adjacent, and hypotenuse is because we use them in something called trigonometric ratios. Does anybody remember what the ratio is a fancy word for? Fraction. Trigonometric ratios. Ratio is just a fancy word for fraction. And then you'll need to know the word, and you don't have to memorize the actual word because it's on your formula chart, but you do need to know what the letters stand for. SOHCAHTOA is an acronym, and it stands for sine, S-I-N-E, opposite, O-P-P, hypotenuse, H-Y-P. Then we get to ka, which is cosine. The A is adjacent. The H is hypotenuse. Then we get to toa. The T is for tangent. It's a different kind of tangent than I went off on a tangent. We'll talk about that kind of tangent, but not till we get to circles. It's a different kind of tangent. Okay. O stands for opposite. A stands for adjacent. When I write the word SOHCAHTOA, I usually don't write it the way you see it first there. I usually write it the second way you see it because that shows me what my ratios are going to look like. The sine of an angle is the ratio of the opposite to the hypotenuse. The cosine of an angle is the ratio of the adjacent to the hypotenuse. And the tangent of an angle is the ratio of the opposite to the adjacent. Okay? So, let's look at our triangles that we looked at at the very beginning of today's lesson with the apple and the bee. And we're going to find the sine, the cosine, and tangent if we're standing at angle A. And then we're going to find the sine, the cosine, and tangent if we're standing at angle B. Okay? The first thing I need to do is if I'm standing at angle A, I need to label my triangle from the perspective of angle A. Which we already did, right? That's the first thing we did was we labeled this triangle. We said the hypotenuse was C. Which one did we say was the adjacent? B. And so this one was my opposite. Okay? The sine is the ratio of the opposite over the hypotenuse. Opposite over the hypotenuse. So the sine of angle A is the opposite has a length of A, and the hypotenuse has a length of C. It's just that ratio reduced. Whatever those numbers are, if it reduces, you do want to reduce it. The cosine, ka, A over H. A is my adjacent, which is B, over H is my hypotenuse, which is C. So B over C. And then toa, my tangent is opposite over adjacent. My opposite is A. My adjacent is B. That's all you have to do is make those fractions and reduce them. That's it. Easy peasy. Okay? But sometimes we're not standing at angle A. Sometimes we're standing at angle B. So if I'm standing at angle B, and I want to find the sine, cosine, and tangent from angle B, then I have to still label my triangle, but this time from angle B. My hypotenuse is not going to move. It's still going to be in the same spot. It's still C. But now where's my adjacent? Where the opposite was, now it's A, right? So now this one is adjacent. And so which one's opposite? B. Alright, so now my sine from angle B, sine is opposite over hypotenuse. My opposite is B. Over the hypotenuse is C. The cosine is adjacent over hypotenuse. So adjacent is A. Over hypotenuse is C. The tangent is opposite over adjacent. My opposite is B. My adjacent is A. Does anybody notice anything about the sine and the cosine when I'm looking at the two different angles? Yeah, they like switch places, right? AC, AC. They switched places there. And then AC, or BC, BC, they switch places there. But my tangent, what do you see about the tangent? It doesn't switch places. What happens with the tangent? Yeah, the numerator and the denominator flips. Do you remember the fancy geometry or math word for flipping fractions?
Reciprocal.
Good, reciprocal. They're going to always be reciprocals of each other, which makes sense, right? Because the opposite and the adjacent flips places. So when you flip the ratio and they flip places, it's going to be reciprocal. Okay? All right, so let's see how this works. Find the sine, cosine, and tangent of the identified angle. So first one, it says find the sine, cosine, tangent with angle A. So that means I'm going to label my triangle from the perspective of this angle right here, angle A. Which length is my hypotenuse, 5, 12, or 13? 13. Which one's the adjacent, 5 or 12? 12, right? Remember to find it. You highlight the two sides coming out of that angle, and the one that's not the hypotenuse is the adjacent. Which means the one I'm yelling at on the opposite side of the room is 5, my opposite. Okay? Once you've labeled your triangle, then you can find your ratios. I will usually write this next to every problem I do this entire unit. Even though I've been doing it for years and I know it. I still like to write it. Alright, because then I can easily see that my sine is opposite over hypotenuse. My opposite is 5. And the hypotenuse is 13. My cosine, A over H, adjacent over hypotenuse. What's my adjacent? 12. What's the hypotenuse? Does that reduce? No. 12 over 13 does not reduce. Tangent is opposite over adjacent. What's my opposite? 5. What's the adjacent? 12. Does that reduce 5 over 12? No. So those are my ratios, sine, cosine, and tangent from angle A. That's it. That's all you got to do. Okay? Let's look at the next triangle. It says to look at angle L. So I'm going to label my triangle with respect to this angle right here, angle L. What length is my hypotenuse? 12, 16, or 20? 20. Which one is the adjacent, 12 or 16? 12. because I'm going to be yelling across the triangle to the opposite side, 16. So, ka, toa. The sine is the ratio or the fraction made by the opposite over the hypotenuse. What's my opposite? 16. What's my hypotenuse? 20. Does that reduce? Yes, to what? 4/5. Cosine is adjacent over hypotenuse, ka. So my adjacent is 12 over my hypotenuse is 20. Does that reduce? Yes, to what? Three what? 3 to 5? Okay. And then my tangent is toa, opposite over adjacent. My opposite is, and my adjacent is 12. Does that reduce? Yes, to 16 over 12? 4 over 3. Okay? One more. All right. The last one, we want sine, cosine, and tangent from angle J. So this time I'm standing up here at angle J. Which one's my hypotenuse? 24, 32, or 40? 40. Out of the two sides coming out of my smiley face, which one's adjacent? 32. Which means the side I'm yelling at on the opposite side is 24. Okay? So, ka, toa. So, ka, toa. Alright. My sine, so, O over H, opposite over hypotenuse. What's my opposite? 24. What's the hypotenuse? 40. What does that reduce to? Remember, if you hate reducing, you can always grab a calculator and do 24 divided by 40. And it'll do it for you, 3/5. You don't even have to think. Cosine, ka, adjacent over H, over hypotenuse. What's my adjacent? 32 over my hypotenuse, 40. Oops, I wrote a 34 instead of a 32. 32 over 40. 4/5. And then my tangent of J, toa, opposite over adjacent. What's the opposite? 24. And what's the adjacent? 32. 24 over 32 reduces to 3/5. Look at my last two examples. Do you notice anything about the last two examples, the answers on them? Compare the sines and the cosines. 4/5, 4/5. Cosine and sine, 3/5, 3/5. And then look here, 4/3, 3. Oh, it wasn't 3/5. What was it? 3/4. But are these the same triangle?
Yes.
Are they? No, because this one's 20 for the hypotenuse, this one's 40. This one's 16, this one's 32, this one's 12, this one's 24. They're not the same triangle, but what kind of triangles are they other than right? How could what would I call their relationship? Not congruent, similar, right? There's a scale factor of 2 to 1 between these, right? Because this triangle is twice as big as this triangle. So if you have similar triangles, their trig ratios will be equal. So for example, every 45-45 triangle you come across in your whole life, since I know the two legs are going to be the exact same length, when I put one leg over the other for opposite over adjacent, I'm going to get the same number over the same number. For every 45-45 90 triangle, I'm going to get an answer of 1. It's going to be the same number over the same number, right? So the tangent of every 45-45 90 triangle will always be 1. Okay? So every similar triangle will have the same trig ratios. Okay? Tomorrow when you come to class, you absolutely do want to make sure you grab a calculator, because we are going to need to use the calculator to do trig. Okay? So tomorrow make sure you grab a calculator to do trig. Your assignment is available for you in Schoology.